Hey everybody, Mr. Rhodey here. Welcome back. Happy May 7th. We're diving into activity 34, which introduces graphing trig functions. We'll have two separate videos today. This first one will focus just on introducing the idea of periodic functions, and the second one will focus on the sine function. So having your unit circle may be helpful, that graphic organizer, to reference those important values of the sine function. Posted in Schoology. You can also download another word wall and graphic organizer for kind of our goals. Again, we are in Unit 6, and in this case, we are trying to graph trig functions is our goal. To start with, in our first lesson, we just want to get an idea of identifying what periodic functions are, and then finding these three big things: the period, the midline, and the amplitude. So those three pieces will go on our word wall at the end of the lesson today. Okay, so we're on page 511 of your notes. Again, I always recommend maybe reading through it yourself, pausing the video as needed to try the problems on your own before seeing me work them. That'll really help you kind of get a good sense of what's going on. So you see our learning goals up top here for page 511. It starts off talking about, can we repeat a pattern? And what you'll notice are these kind of wavy looking graphs. And so this idea of repetitive motion, rotating around the circle like we have already, that's what this idea of trig gets to. And so it'll actually help in future applications such as waves in physics or wavelengths. All of our broadcasts are in waves that look like this. So whether that's Wi-Fi signal, cell phone signal, TV, radio, it all travels in waves. And so these top two are what we consider a periodic function, and it repeats its values in regular intervals called periods. And then down here, you'll notice even though this has got this wave idea, this is not periodic. Okay, the big reason it's not periodic is because the pattern doesn't repeat. It's actually getting smaller as you go through it. That's still important. It's still oscillating, but it's not oscillating at regular intervals, and that's bad. The signal is degrading, so to speak, on a Wi-Fi signal. We want it to be strong and repetitive. So again, check your understanding. Go ahead and hit pause here. Try and sketch the graph of your own periodic function, and then sketch a graph of one that is not periodic. So try that on your own, and then we'll pick it up on page 512. Okay, here on page 512, we're going to look at this repeating pattern and identify some key pieces of it. So the first is the period, and it's the horizontal distance for this cycle. If we notice, this particular one is going to go up and then down and then up again. So this horizontal distance is going to be our period or length of the cycle. So if you draw this kind of rectangle around it, you can see what that is. The amplitude of a function is half the distance between the minimum and maximum values. So if you're thinking about it, this would be the maximum, this would be the minimum. So the total distance up and down, if I take half of that, that's just how much it rises from the middle or how much it falls from the middle. So that's why the amplitude's only half of that vertical distance. And then finally, the midline, where is that middle? Where is that center that it's oscillating from? That midline goes directly through the middle there. So it's really in between the max and min. So what's the middle of the max and min? Midline. And what's half the max minus the min? That's the amplitude. And so they show you some of these calculations here, in particular on this particular graph in the book. So let's look at a couple together. If you want to pause and try them yourself to find the period, amplitude, and midline, go ahead and pause, try that again, and compare them against my answers. But I'll go ahead and look at this. So how do you look at it? You analyze it. I see a repeating pattern. You can start the repeating pattern in a lot of different spots. I'm going to go ahead and just look at it from here to here. So I'm drawing a rectangle around that repeating pattern. So that V shape is going to repeat, repeat, repeat. Okay. So I've done that. How wide is the rectangle? This is going from 0 all the way to 8, so it is 8 wide, and which feature? That is our period, right? The width is the period. How high is the rectangle? Let me switch colors for that, actually. How high is the rectangle? I'm at 2 here and -4 here, so that's actually a total of 6, right? So if I want to think about that, that's 2 minus -4, that equals 6. And so the height is 6. But the amplitude, of course, is only going to be half of that. So the amplitude is equal to 6 divided by 2, or 3. So my amplitude is 3. And then finally, the midline of our function here, I'll draw that in black, halfway between -4 and 6. So -4 and 2, so -4 plus 2. If I take the average of those, -2 divided by 2 equals -1, so it's y equals -1. In reality, it's 3 down from 2 or 3 up from -4. So my midline, visually it's pretty easy to see, but y equals -1 would be my midline there. Okay, let's look at a couple more examples, and then you should be ready to try the first half of your homework. And then the second video will be about specifically what does the sine graph look like with these ideas. So here we are on page 513, looking to analyze these particular graphs. And so I encourage you to try to answer them on your own and then take a look at my answer. So is it periodic or not? And if it is, let's find those three important values: the period, the amplitude, and the midline. So for number 4 here, I'm going to go ahead and take a look at, let's see here. This looks like it repeats this kind of V or U shape. And so width-wise, it's got a width of 3. Height-wise, it's got a height of 8. And so as I think about that, that is periodic. So its period is equal to 3. Its amplitude is half of its height. So that's 8 divided by 4, but, sorry, 8 divided by 2. So its amplitude is 4. And its midline is going to be at y equals, let's see here, 6 and -2. That's 4 divided by 2, so that's 2. Y equals 2 would be the midline. And again, visually, that should be pretty easy to see as well. So period of 3, amplitude of 4, midline of y equals 2. Letter 5, looking at that one, hope you're recognizing this is not periodic. If you're looking to justify why it's not periodic, it's because the wave is there, but the amplitude is changing. So it's not repeating the same amplitude. It's not repeating the same wave over and over again. On number 6, we do get some repetition here, except it's been shifted a little bit. So again, it's easy for me to see these on the V shape. So I'm just going to draw that over here and over here. So from -2 to 14, that's a width of 16. And then from -8 up to +2, that's a height of 10. So my period on this particular one is equal to 16. My amplitude, 10 divided by 2, is going to be 5. And my midline, it's horizontal, so it's y equals. Between -8 and 2, so that's going to be -6, so -3. -3. And again, how did I figure that out? I just took the minimum, maximum, -8 plus 2 divided by 2. That's my midline idea. Okay. Again, we've seen these words before, maximum and minimum. The maximum is the highest y value of the graph. The minimum is the lowest y value of the graph. And so obviously the amplitude, if we're really thinking about that, it's really the max minus the min divided by 2, right? I'm getting max minus min will give me that full height, and then that height I got to divide it by 2. Meanwhile, the midline, as I'm thinking about it, is basically the max plus the min, because I'm doing the average. The max plus the min divided by 2. So it gives you a nice way of getting those, and it might be a good thing to put on your word wall as well. So you got a few examples like that for your first assignment, and then we'll pick it back up in the second video talking specifically about the sine graph and how it has different periods, amplitudes, and midlines. So here are the word wall definitions of periodic function: period, amplitude, and midline. Again, the only thing you may want to add to these, you can pause as you need to copy them down, but the horizontal distance for the period should be pretty obvious. The amplitude, on the other hand, as you're looking at that, you might want to use that little formula that we talked about, that peak valley idea, where the amplitude is the max minus the min divided by 2, while the midline was the max plus the min divided by 2. I don't love just giving you formulas for everything. I'd rather have you kind of conceptually understand it, but if you appreciate those, there they are. First homework should be pretty quick. And then we'll come back with the second lesson for today on just sine of theta and how to graph that.